And there's some other kind of random ones that assign extension opcodes. And strangely enough, you can actually debug these C programs to a limited degree. LLVM will generate dwarf debug information for you, so I can just dump that into the SWIFT as binary data. I can dump some of the other, sort of higher level information as arrays and maps and so forth in the ActionScript itself. And basically, I have a little tiny implementation of GDB's machine protocol in the SWIFT actually burned in. And again, since these are chains of finite state machines, you can just hang that off somewhere and go off and talk on the socket to Eclipse or whatever, or Xcode. And then just sort of resume it when someone hits play again. So I should have prepared a demo for that, sorry. If anyone, I'll try and get it working after the talk if anyone wants to see it. And so for actually doing kind of just chunks of C code that interface with ActionScript, it's, with an application you can just sort of build it and run it. But you need kind of a glue layer if you want your ActionScript code to be able to talk to C code as like a library. So in a sort of matrix-esque way, there's this C API that looks suspiciously like you're a C program embedding an interpreter of some sort. Of course, it's actually the opposite. But from the C point of view, you have handles on ActionScript values, and they're ref counted, and you create strings and sort of all that nifty stuff. And here's kind of a very simple use of it. We just have like a main that just does some random stuff. This acquires the date class and constructs it with empty parameters and feeds it to trace, so you'd see the date pop out in your debug log if you ran this in the Flash debugger. And you use this to sort of create an ActionScript object that can interface with your C code effectively. So what we have here is we have kind of a thunk that ActionScript knows how to call here. It's a C function, but it returns one of these ActionScript handles, takes in a handle to an ActionScript array for the parameter list and so forth. And in your main, you basically just construct an object with name value pairs, typically functions. So some entry here is going to be a property of an ActionScript object created by this call that is actually going to contain a thunk to this, and pass that object to the I'm done initializing my library call. And so from the ActionScript side, hopefully this is somewhat readable, you can just sort of create the object representing the library as a whole, initialize it, and this returns the value that we pass to AS3lib init. So basically you get an ActionScript object out that again has functions on it that you can just call from ActionScript land, and that sort of does all of the basic marshalling and so forth. And at some point it had occurred to me that there's a whole class of C and C++ programs that were especially interesting, and that is interpreters. For example, the Python interpreter is all C, Lua interpreter is all C, Ruby interpreter, all C. And so why not take a code base like that and make it into a library callable from ActionScript? And it turns out that you can basically just take Python /configure make, and you can take that header file for the sort of glue layer, the C manipulating ActionScript objects layer, and run it through something called swig, which is basically a glue code generator that can take C header files, parse them, and generate glue code for a large number of languages, various flavors of PHP, Lua, et cetera, et cetera. Link that all in and get basically a gigantor Flash SWIC out that is the Python interpreter with the ability to communicate with the ActionScript environment. And so once you have that, you can write some nifty little wrapper Python here. All this stuff really does is sort of masquerading as ActionScript objects. So, when you do a get adder, when you try to get the attribute of one of these things, it calls in through all those crazy ActionScript functions saying, do you have this attribute? Yes. What type is it? Let's marshal it over. Which lets you basically write Python code. So this is fairly simple Python code, but you see it's just basically calling straight into the Flash API here. So flash.display.sprite, and it's sort of creating a circle effectively and adding some event listeners here, and it's just, it's just passing Python closures right in as event handlers to ActionScript, and that's all marshaled totally transparently. And while you'll have to use your imagination and imagine a little bit better demo, I do have that Python running in the Flash player. So every Python code created all these circles. Every time I click them, it's Python responding to the events. Every time it updates, there's Python code running. I've got one more. Let's see. So this is the Lua interpreter, and this one I've just decided to leave interactive. So I can do, for example, print 6 or whatever, and we'll ignore the debug output for the moment. The problem with booting Linux, I would love to get there. So have I booted Linux yet? So the big problem with booting Linux, and yes, that question has been asked a couple of times, is this system is effectively a Harvard architecture, which isn't totally compatible with the Linux kernel design. There's no sort of real reason you couldn't boot something up that was boot up more or less anything that is kind of Harvard architecture. So this is some Lua code, and again, it's fairly similar to the Python you saw. It's just happily going off and creating Flash shapes and so forth. And I can just paste that code in there, and we create a nice little sun, and I can throw a little more code in there and make it follow the mouse just for fun. And what is a little bit interesting about this is the loop following the mouse is just a while one. And again, because of the asynchronicity, I can just do a yield here, right in the middle of my infinite loop. And let's see, I guess that's about all of my slides. I did have one more demo. The stack here is kind of huge. I probably should have had a slide on it, but it's a little too disgusting to actually commit to paper. But you have, like in the Lua case, you've got Lua code running on top of a C-based Lua interpreter that, if you want to be pedantic, went to llvm-ir and then went to ActionScript and then went to ActionScript bytecode, which is then, converted to, believe it or not, another IR in the Flash player before it's JITted to x86 code and then run as x86. But I decided to do something